Welcome to the General Chemistry 1 class. This section is on mass relationships in chemical reactions, focusing on mole ratio. In this lesson, we will construct mole or mass ratios for a reaction in order to calculate the amount of reactant needed or amount of product formed in terms of moles or mass. The coefficients in chemical equations can be thought as the number of moles of each substance involved in the reaction. Hence, those coefficients are called stoichiometric coefficients. For a hypothetical equation, 2A forming 3B. It is possible to determine the amount of A needed to produce a certain amount of B, or the amount of B can be formed given a certain amount of A with the use of their mole ratio from the balanced chemical equation. Going back to the same reaction, the equation can be interpreted as 2 moles of A produces 3 moles of B. From here, the mole ratio showing the relationship of A and B can be expressed as 2 moles of A is to 3 moles of B, or 3 moles of A is to 2 moles of B. To determine which mole ratio is useful to a certain calculation, remember that the aim is always to cancel the given unit and convert it into the desired unit. For instance, to find the number of mole of A needed to produce 6.0 mole of B, mole of A equals 6 moles of B times 2 moles of A over 3 moles of B. This way, moles of B is cancelled and the answer is already converted to A. Simplifying, we get 4 moles of A, and on the other hand, to find the number of moles of B produced from 8.0 moles A, the mole of B is equals to that 8 moles times 3 moles of B over 2 moles of A. Canceling the unit of moles of B, we are left with a unit of moles of B. By simplifying the equation, we get 12 moles of A. Stoichiometric calculations involving amounts of reactants and products can be simplified as shown in the diagram. The general steps in doing these calculations are: first, make the chemical equation for the reaction is balanced. Second, use molar mass to convert mass to moles and vice versa. Third, use the mole ratio from the balanced chemical equation to convert moles of given substance to moles of another substance. Let us apply these steps to some examples. Copper can be dissolved in nitric acid according to the reaction. We have 1 mole of copper plus 4 moles of nitric acid, yielding 1 mole of copper to nitrate and 2 moles of nitrogen dioxide and 2 moles of water. Question number 1. How many moles of water are generated from 0.0245 moles of copper? Question number 2. How many moles of nitrogen dioxide are produced when 3.11 grams of copper is used in the reaction? And lastly, question number 3. How many grams of copper are required to generate 4.26 grams of copper to nitrate? Before we proceed, let us make sure the equation is balanced. The equation given to us is already balanced. But it will always be a must that you should check prior to performing calculations. Since the equation is balanced, we can now start our calculations. For the first question, we are concerned with the conversion of moles of copper to moles of water. By looking at the diagram, notice that we only need the mole ratio of copper and water as stated in the chemical equation. To find the moles of water, multiply 0.0245 moles of copper by the mole ratio. Based on the chemical equation, there are 2 moles of water for every 1 mole of copper. Since our goal is to convert moles of copper to mole of water, the mole ratio is then 2 moles of water over 1 mole of copper. Simplifying the equation, we have 0.0490 moles of water. For the second equation, the calculation involves the conversion of mass of copper to moles of nitrogen dioxide. Looking at the diagram, the necessary conversion factors are the molar mass of copper and the mole ratio of copper and nitrogen dioxide based on the chemical equation. The number of moles of nitrogen dioxide is equal to 3.11 grams of copper divided by the molar mass of copper times the mole ratio. From the chemical equation, there are 2 moles of nitrogen dioxide per mole of copper. Hence, the mole ratio is 2 moles of nitrogen dioxide per 1 mole of copper. Plugging in all values, moles of nitrogen dioxide equals 3.11 grams of copper times 1 mole of copper over 63.55 grams copper times 2 moles of nitrogen dioxide over 1 mole copper. For the answer, we have 0.0979 moles of nitrogen dioxide. For the third question, the mass of copper to nitrate has to be converted to the mass of copper. From the diagram, the conversion involves the use of molar mass of copper to nitrate, mole ratio of copper and copper to nitrate, and the molar mass of copper. For the solution, the mass in grams of copper equals 4.26 grams of copper to nitrate divided by the molar mass of the copper to nitrate times the mole ratio converting moles copper to nitrate to mole copper times molar mass of copper. The molar mass of copper nitrate is 187.57 grams per mole. If you need guidance in how this value was calculated, you may check your periodic table for the value of the molar mass of elements and refer to our previous discussion on calculating molar mass of compounds. The mole ratio to be used is 1 mole copper per 1 mole of copper to nitrate, and the molar mass of copper is 63.55 grams per mole. Simplifying the equation, we obtained 1.44 grams of copper. Let's have example number 2. For example number 1, congratulations, you did a great job. Now, let us move to more complex one. Example number 2. Nitromethane, a compound used as fuel, is burned according to the reaction. 4 moles of nitromethane plus or combined with 3 moles of oxygen, yielding 4 moles of carbon dioxide and 6 moles of water and 2 moles of nitrogen. Question number 1. How many grams of nitromethane are needed to generate 1.846 grams of N2? Question number 2. How many grams of oxygen are needed to consume 1.211 mole of nitromethane? Notice that a given chemical equation is balanced, so we can now proceed to performing calculations. The first equation involves conversion of mass of nitrogen to mass of nitromethane. From the diagram, we will need the molar mass of nitrogen, the mole ratio of nitrogen, and the nitromethane from the chemical equation, and molar mass of nitromethane. The mass of nitromethane is then equal to 1.846 grams of nitrogen divided by the molar mass of nitrogen molecule, which is 28.02 grams per mole, times the mole ratio 4 moles of nitromethane per 2 moles of nitrogen times the molar mass of nitromethane, which is 61.0454 grams per mole. Again, check your periodic table for the molar mass of elements used. Simplifying the equation, we have 8.043 grams of nitromethane. For the second equation, the given moles of reactant is to be converted to moles of another reactant. Although our previous examples deal with the conversion of amounts of reactants to a product or vice versa, same as the rule discussed shall be applied for the problem. As reflected on the diagram, conversion of nitromethane to oxygen includes the mole ratio of oxygen to nitromethane and molar mass of gas as our conversion factor. From the chemical equation, the mole ratio of oxygen and nitromethane is 3:3. Hence, mass in grams of oxygen equals 1.211 moles of nitromethane times the mole ratio 3 moles of oxygen over 4 moles of nitromethane times the molar mass of oxygen, which is 32 grams per mole. Simplifying, we get 29.06 grams of oxygen. To summarize, the mole ratio is the ratio of the coefficient of two substances in the balanced chemical equation. It helps in converting the amount of a reactant or product to the amount of another substance involved in the reaction. We have here our references or bibliography. Thank you and God bless.